In today's video, we're going to discuss the open question in computer science: is the complexity class NP equals the complexity class CoNP? But before getting into the action, let's match our expectations. My videos depend on the wisdom of the crowd, a topic that really fascinates me. Since I'm studying this topic by myself, there might be an occasional mistake in what I say. Please let me know in the comment section below if you wish to correct me, of course. I promise to read all comments and re-upload if necessary. Together, we can answer tough questions in a better way. Also, please subscribe to my channel. I tend to upload many videos on this topic. To understand that question better, we would look at the bottom of the polynomial hierarchy and make a challenge for ourselves. Let's jump right into it. Alrighty, is complexity class NP equals complexity class CoNP? That's an open question. Although we assume that the answer for it is no, so the complexity classes NP is not equal to the complexity classes CoNP, it is worth mentioning that the class NL equals CoNL, but that discussion is for another day. To understand this question, we would look at the first two levels of the polynomial hierarchy. The first scenario is the one on which the polynomial hierarchy is based on. As we can see, the conjunction of classes NP and CoNP is not empty, but both classes NP and CoNP have problems its complement does not. On the other hand, we can see that P is a subset of both complexity classes NP and CoNP. Therefore, third scenario, if P equals NP, we can conclude immediately that CoNP equals NP as well. On the other hand, the second direction is not a conclusion of a positive answer to the question, is NP equals CoNP? In other words, say we prove NP equals CoNP, we cannot conclude that P equals NP. Second scenario. With that knowledge in mind, we would practice the idea of this open question with the following challenge. We would say that set S, which is a subset of the set 0 and 1 clean star, any combination of zeros and ones of any length, is writable NP problem. If there is a polynomial P and a polynomial algorithm A, so for any input X, the output of algorithm A on input X is either an invalid sign or all words in set S which their length is identical to the length of input X. For example, say S is the set of strings 1, 1, 0, 0, 1, 1, 1, 0, 0, and 1, 1, 1, and X is the string 0, 0, then the output of algorithm A will be either the invalid sign or 1, 0, 0, 1, 1, 1, and 0, 0, because these are all the words in S with the identical length of the input X. Its length is 2, of course. Additionally, for any input X, there is a Y, so AXY prints all words of S with the length of input X. We want to prove that if problem S is in NP and there is a group S prime which is writable NP problem such that there is a hook reduction from problem S to problem S prime, then NP equals CoNP. Solution. We would notice that it is enough to say that CoNP is a subset of NP. That's because that if problem S belongs to NP, then its complement problem is in CoNP. And if we would manage to prove that CoNP is a subset of NP, then the original problem S is also in CoNP. Be problem S in NP, then there is a problem S prime in NP that is writable NP problem. And according to the assumption, there is a quick reduction from problem S to problem S prime. We know that there is a quick reduction from the complement problem of S to S prime, and therefore there is a polynomial non-deterministic algorithm with an oracle access to S prime. Additionally, because S prime is writable NP problem, there is an algorithm AS prime and a polynomial P that solves S prime in a polynomial time. We would now describe the algorithm B that solves S complement without an oracle access. The algorithm B. Given input X, algorithm B would act identically to algorithm AS prime xy. And whenever algorithm AS prime refers to the oracle and asks it a question of the type, does the query Q belongs to S? Algorithm B, which can't access the oracle, would randomize wise and run them using AS prime until all words of the identical length of input X return. The algorithm will not run forever, because for any input X there is a Y, such that the algorithm return all words of the length of X. Once completed, we would scan the output and check if the input X is one of the words. If it is, we would return yes, otherwise we would return no. That way, we can solve the complement problem of S. We would notice that we use the non-deterministic algorithms AS prime without an oracle access and AS prime with an oracle access, and therefore S complement belong to complexity class NP as well. In conclusion, we proved that given a problem in CoNP and all the additional information provided, then that problem is also in NP. Therefore, CoNP is a subset of NP, and NP is a subset of CoNP, and therefore NP equals CoNP, as required. Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that. Please subscribe to my channel. Until next time, bye bye!